All right, so today we are going to look at how to solve for the unknown side of a triangle using our trigonometry ratios. So to begin with, we're going to practice the skills that we already know. We're going to label our triangle. So we have our theta here. We need to label our opposite, adjacent, hypotenuse. So our hypotenuse is the longest side. Our opposite is the side that is directly opposite from the angle. And our adjacent is the side that is right next to the angle. So we've labeled O, H, and A. Then we're going to look at what we have been provided. It helps if you write it out. Do we have O? Do we have A? Do we have H? Do we have theta? We know that O in this case is equal to X. We know that A in this case, there is nothing provided. We know that H is equal to 5. And we know that theta is equal to 30 degrees. So if I look at this information at what has been provided, I see that I have O, I have H, and I have theta. So I need a trigonometry function that has O, H, and theta. Now I know that sine of theta is equal to O over H. So that's going to have everything I need. It has my theta, has my opposite, has my hypotenuse. So the first step is label. The second step is identify which ratio you need to use. The third step is substitute. So my theta is 30 degrees. I'm going to say sine of 30 degrees is equal to my opposite, which is x, divided by my hypotenuse, which is 5. Now, we're going to transpose this equation to get x on its own. So this goes back to your linear algebra skills. So if we want to get x on its own, the step that we need to do here is multiply both sides by 5. So what we will be left with is 5 times sine of 30 degrees is equal to x. Now we know what x is equal to in exact form. We're going to put it into our calculator to get the final answer. So if I bring up my calculator, I'm going to get sine of 30 degrees, which is 0.5, and I'm going to times that by 5. And I get 2.5. So I now know that x in this case is equal to 2.5. Now in this case, no units have been provided. If units are provided, please do not forget to write units on your answers. Moving on to the next example. Once again, step 1, I'm going to label my diagram. This here is my theta, which means that my hypotenuse is the longest side, opposite is the side opposite to the angle, and adjacent is the side that touches the angle that is not the hypotenuse. I'm going to see what I've been provided with. So O, A, H, and theta. My opposite, I have nothing. My adjacent is x, my hypotenuse is 10, and my theta is 45 degrees. Now it's important to recognize at this point that if they ask me to solve for x, even though I don't have a value for x, it's going to be part of my equation. So the side you're looking for must be included in your ratio. Now I have A, H, and O, so I'm going to be using my cosine formula. Cosine of theta is equal to adjacent over hypotenuse. Does it have my theta value? Yes. Does it have an adjacent? Yes. Does it have hypotenuse? Yes. I substitute cos of 45 degrees is equal to x over 10. Again, you'll see that x is a numerator. There is a denominator I have to remove. In this case, it is 10. So to remove the 10, I'm going to multiply by 10 on both sides. This will leave me with 10 times cos of 45 degrees is equal to x. And I'm going to throw all of this into a calculator. So I find cos of 45 degrees. I'm going to multiply that by 10. Now, no decimal places have been given at this point, so I'm just going to do it to 2 decimal places, which would be 7.07. So in this case, we're going to have x is equal to 7.07, and the units are meters. So 7.07 meters. The final example we're going to look at today, we're going to follow the exact same steps. We're going to label our hypotenuse. We're going to label our opposite. We're going to label our adjacent. We're going to list what we have. OAH, theta. We know the opposite is x. We know the adjacent is 7. We know the hypotenuse is not provided. We know that theta, in this case, is 60 degrees. If I'm looking for OA and theta, I'm going to be using my tan, or tangent, ratio. Tan of theta is equal to x over 7. I substitute. Tan of 60 degrees is equal to, apologies, x over 7. Your default formula is tan of theta degrees is equal to opposite over adjacent. And therefore, my opposite is x. And in this case, my adjacent is 7. Now, once again, I have a denominator of 7, so I'm going to multiply by 7 to get x on its own. And that's going to give me 7 times tan of 60 degrees is equal to x. I'm going to throw it into a calculator. 60 degrees tan times 7 is 12.12. So I'm going to have a final answer of x is equal to 12.12 centimeters. And that is how you apply your trigonometry ratios to solve for the unknown side of a right angle triangle. Good luck.